This is ChainMind, the decentralized AI network built for everyone. Just search ChainMind on Google, sign up, download the app, and you're in. That's it. You've joined the network. Run it on any device, phone, laptop, or server. Why ChainMind? Fully decentralized, fully yours.
Imagine a cat perched on a piano bench, its paw hesitating over a single key, and the soft note that rings out like a secret waiting to be heard. What if that fleeting, accidental melody could be captured, refined, and turned into a track that plays in clubs across the world? That whimsical scene is the spark behind a new kind of AI, one that lives not in a single data center but in the pockets of anyone who has a spare processor, a curious pet, or a burst of creative energy. The first idea we'll explore is why a cat's random keystrokes matter at all. It isn't just a cute internet meme, it's a proof that data can spring from the most unexpected corners of everyday life. When a feline taps a piano, it creates a tiny rhythm, a series of pitches, and a timing pattern that no human composer would have thought to write. In traditional AI pipelines, that kind of data would be tossed aside because it doesn't fit a curated training set. Centralized servers thrive on clean, large-scale datasets and often ignore the noisy, low-budget recordings that happen in living rooms. Decentralized inference flips that script. Instead of funneling every sound into a monolithic cloud, each participant processes the audio on their own device, contributes a slice of model work, and earns a reward for doing so. The result is a richer, more diverse pool of musical material that reflects real life, not just studio perfection. The cat's improvisation becomes a seed for a community-driven music model, one that learns the quirks of spontaneous play just as easily as it learns the precision of a grand concert hall. Next, let's unpack how ChainMind actually makes this happen. The architecture rests on three pillars: edge compute, token-based incentives, and immutable provenance. Edge compute means that any device, your phone, a Raspberry Pi, a homegrown AI accelerator, can run inference jobs locally. When you upload a short clip of your cat's paw pressing a key, the network slices the task into bite-sized pieces, sends each piece to a node that has spare cycles, and then stitches the results back together into a refined musical phrase. Tokens flow to the nodes that contributed, measured not just by raw horsepower but by latency, reliability, and the quality of the output. Because the work happens close to the source, the latency drops dramatically. You can hear a transformed version of the cat's melody in near real time, opening the door to interactive creation that would be impossible if every millisecond had to travel across oceans to a central server. Now imagine the full production pipeline, from paw press to polished track, and see how each stage benefits from a decentralized approach. First, audio capture and pre-processing. Edge nodes clean the recording, strip out background hum, and segment the clip into individual node events. Then comes pitch detection and transcription, where distributed models convert each acoustic blip into a precise MIDI note. After that, a community-trained generative model adds harmonies, rhythms, or counter-melodies that complement the original improvisation. Finally, lightweight inference engines handle mixing and mastering, applying reverb, EQ, and compression to produce a ready-to-stream file. Because each step can be assigned to the node best suited for it, perhaps a laptop with a strong GPU handles pitch detection while a tiny microcontroller excels at noise reduction. The final product often exceeds what a single centralized service could deliver. The diversity of hardware and expertise creates a collaborative tapestry that turns a simple cat note into a fully arranged piece. But here's the part most people get wrong: the value of odd data isn't a novelty, it's a strategic advantage. Traditional AI models discard outlier recordings because they don't fit a neat, labeled dataset. In a decentralized network, those outliers become the foundation for new, niche models. Thousands of cat piano sessions, each with its own timing quirks and emotional undertones, can be aggregated into a specialized model that understands informal, homegrown music creation. That model can then be fine-tuned for broader applications. Think background scores that adapt to the ambience of a small indie game, therapeutic soundscapes that respond to a patient's breathing, or even robotic musicians that react to human gestures in real time. The key insight is that decentralization turns what was once considered noise into a valuable signal, expanding the creative vocabulary available to anyone with a microphone. The third pillar we need to discuss is the tokenomics that keep the whole ecosystem humming. ChainMind's native token does more than pay for compute, it aligns incentives across the entire community. Compute providers earn tokens proportional to the cycles they allocate and the speed at which they return results. There are quality bonuses for inferences that pass community-voted thresholds, encouraging participants to continuously improve their models. Token holders can stake their assets to influence governance, proposing upgrades, setting model inclusion criteria, or adjusting fee structures. This multi-layered reward system ensures that high-performing contributors are recognized, that the network remains economically sustainable, and that decision-making stays in the hands of those who actually use the platform. In practice, a hobbyist who runs a spare GPU at night can earn enough tokens to cover the cost of a new piece of hardware, while a professional composer can use earned tokens to access premium models without paying a traditional subscription fee. Security and privacy are often the elephant in the room when personal audio is processed across a distributed network. ChainMind tackles this with a combination of encryption and zero-knowledge proofs. Your cat's recording is encrypted end-to-end. Only you hold the decryption key. Nodes perform inference on encrypted tensors, returning results that remain encrypted until they reach your device. This means no third party can reconstruct the original audio without your explicit permission. Every inference transaction is recorded on an immutable ledger, creating an auditable trail that anyone can inspect for compliance or dispute resolution. You can verify that your data was processed correctly and that the reward distribution matched the work performed, building trust in a system that otherwise might feel opaque. Let's bring these ideas into the real world with a few concrete scenarios. In a home studio, a musician could capture the sound of rain on a window, a child's giggle, or a cat's accidental melody, and instantly feed those recordings into the ChainMind network. The decentralized models would clean the audio, transcribe the rhythm, and suggest harmonic layers, delivering a ready-to-use sample within seconds. In therapeutic settings, clinicians could upload patient-generated sounds, perhaps a heartbeat or a whispered phrase, and receive personalized, adaptive compositions that help calm anxiety or guide meditation, all while preserving patient privacy. On stage, an artist could stream live audience noises, including pet sounds, to a decentralized inference layer that weaves them into the performance in real time, turning every listener into a co-composer. Even schools could set up low-cost edge devices, letting students experiment with AI-driven music creation without paying for expensive cloud services. Each of these use cases hinges on the same principle: the ability to process unconventional audio inputs at scale, without a central bottleneck, and to reward every participant who makes that possible. Of course, the road ahead is not without hurdles. Network latency can be unpredictable, making true real-time guarantees a challenge for high-precision tasks. Keeping model versions synchronized across a distributed set of nodes requires robust consensus mechanisms to prevent fragmentation. And perhaps most importantly, we need to educate a broad audience about token economics, privacy safeguards, and the responsibilities that come with contributing compute power. ChainMind is already experimenting with adaptive routing algorithms that prioritize low-latency nodes for time-critical jobs, on-chain governance frameworks that streamline model updates, and intuitive dashboards that demystify token flows for non-technical users. By iterating openly with the community, the platform aims to turn each obstacle into a collaborative opportunity, ensuring that the network grows stronger with every new participant. So the next time you see a cat tentatively tap a piano key, remember that tiny paw press is more than a cute video, it's a data point that could spark a global symphony. Decentralized AI inference networks like ChainMind turn those spontaneous sounds into building blocks for richer, more inclusive artistic ecosystems. By rewarding the compute that powers these transformations, we empower creators, hobbyists, and even pet owners to shape the future of music generation together. If you're a composer hunting for fresh inspiration, a developer with spare GPU cycles, or simply someone who enjoys watching a cat discover the magic of a note, join the movement. Follow ChainMind, start contributing your edge compute, and let the world hear the music hidden in everyday moments. The future of collaborative AI-driven art is waiting, and it starts with the next paw press on a piano key.